Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing chemical reaction of amines. Under that I have discussed basic character of amines, and in that I have discussed alkyl amine versus ammonia. Now I am going to discuss alkyl amines versus ammonia, aryl amines. Alkyl already have discussed. Now I am going to discuss aryl amines versus ammonia. pKb value of aniline is quite high. Why is it so? pKb value of ammonia is quite high. Why is it so? It is because in aniline or other aryl amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair of nitrogen atom to be in conjugation with benzene ring, and thus making it less available for protonation. Correct? Why I told you that why you can say this pKb value of aniline is quite high. What is its reason? Then I am telling you, it is because an aniline or other aryl amines, the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be conjugated with benzene ring, and thus making it less available for protonation. If you will write different resonating structure of aniline, you will find that aniline is a resonance hybrid of the 5 structure, and lone pair electron that will donate and it will make a double bond. NH2 is joined with benzene with single bond, but now this lone pair electron can donate, and now single bond will become double bond, and now ring double bond was there close to that carbon through which NH2 joined. That will become single bond, and it will take electron and it will become negative. Means in ring double bond will become single bond, and next carbon will take a electron and will be negative, and after that this will transfer to the this electron that will make double bond with next carbon, and next double bond will again break. Correct? And that carbon will take negative, that will become negative charge. This carbon will take electron and will become negative. Like that way it will switch to the other carbon. Means a carbon which will take electron that will make double bond, okay, with the next carbon, and next double bond will break. Like that way in 5, in total 4 you can tell, in total 4 negative charge will be completely delocalized from the carbon number you can tell 2 to carbon number 6, means ortho position, to again it will come to next side ortho position, means ortho, meta, para, again again meta, and then ortho. Means you will give the number of carbon number, then this from 1 to 6, it will revolve from negative charge will just delocalized from the carbon number 2 to carbon number 6. With carbon number 1, NH2 is attached. Then carbon number electron was with carbon number 2 and it was negatively charged. That will just it will delocalized. Okay, and it will reach to the 6 in 4 structure. Finally, again what will happen, that when negative charge will reach to the 6 carbon, then there it will make double bond with 6 and 1, and where double bond was there, that will again go to the original place. Means double bond will become single bond. And what was the charge after donating the electron? Nitrogen became positive charge. Now after taking the electron back, that positive charge will go, it will become neutral. Then this is actually resonance structure. Total 5. 4, finally 1 structure, 5. But here if you will see that this thing, anilinium ion ion obtained by accepting a proton can have only 2 resonating structure. Correct? Anilinium ion means when NH3 is joined to the benzene ring, that is a anilinium ion. Correct? NH3, and that N is positive. Then there only 2 resonating structure is possible. Only 2. Okay. Then 2 structure means here only 2 resonating structure. That one was the original double bond ring and double bond with the carbon to which NH3 was attached. That with that carbon and second carbon, between 1 and 2 double bond was there. Now second possibility is that 1 and 6 will make 1 and 6 will be double bond. Only 2 possibilities there. Okay. Then here I told you why pKb value of aniline is high. Okay. Then aniline, you can tell other name of aniline is alkyl amine. Other name of aniline is alkyl amine. Okay. Now further I am telling you, greater the number of resonating structure, greater is the stability. Correct? Then here you have seen with in the case of aniline, total 5 structure was there. That's why that structure is stable. And NH2, that N got positive charge. That's why it is more basic. Okay, this structure is stable and plus charge is on N. That's why it is basic. But here in anilinium ion, when NH3 is joined, not NH2, NH3, then only 2 structure is there. Only 2 resonating structure is there. Then from this we can conclude that greater the number of resonating structure, greater is the stability. Okay. Aniline has 5 resonating structure, is more stable than anilinium ion. Hence the proton acceptability or the basic nature of aniline or other aromatic amines would be less than that of ammonia. Okay. This proton acceptability or the basic nature of aniline or other aromatic amines would be less than that of ammonia. Okay. In case of substituted aniline, it is observed that electron releasing group like OCH3, CH3 increase the basic strength, whereas electron withdrawing groups like NO2, SO3H, COOH, halide ion decrease it. Okay. Then aniline is, if you compared, already I discussed, in comparison to ammonia. In comparison to ammonia, aniline is weak. Okay. Aniline is weak basic in comparison to ammonia. Okay, already I have discussed. Okay, basic nature of aniline or other aromatic amines would be less than that of ammonia, you remember. Now, substituent effect you can see. In case of substituted aniline, it is observed that electron releasing group, actually OCH3 is electron releasing, means it will supply the electron. Methyl group is also like that. Both are electron releasing group. Correct? It increases the basic strength because it will supply the electron to the N, and N can donate the electron. Then it will be that in this situation it will be more basic. And when any group which withdraw the electron, that will be due to that group, that aniline will be weak. It will show weak basic strength. Okay. Then example is withdrawing group like NO2, SO3H, COOH and X decreases the basicity. Okay, this group decreases the basicity, but OCH3 and CH3 increases the basicity. Okay, now next properties I am telling you, that is the acylation. It goes alkylation also, already we have discussed. Amines undergo alkylation on reaction with alkyl halides. Many times I have discussed. I will discuss now acylation properties. Okay, this is very, very important. Alkylation, many times I discussed. It is easy also. Acylation. Aliphatic and aromatic primary and secondary amines react with acid chloride. It also reacts with anhydrides and esters by nucleophilic substitution reaction. Aliphatic and aromatic primary and secondary amines react with acid chlorides, anhydrides and esters by nucleophilic substitution reaction. This reaction is known as acylation. Okay, this reaction takes place as the replacement of hydrogen atom of NH2. Means from the NH2, 2H is there, then it will be replaced. Okay, this reaction as the replacement of, this reaction takes place as the replacement of hydrogen atom of NH2 or NH group by an acyl group. Replacement only, remember, hydrogen will go and in its place acyl group will come. The procedure, the products obtained by acylation reactions are known as amides. Okay, this reaction actually also I have discussed. Okay, anyhow again I will tell you the reaction, or you can tell the products obtained by acylation reactions are known as amides. The reaction is carried out in the presence of a base stronger than amine, like as for example pyridine, which remove the HCl. Pyridine is base. Pyridine has basic character. It is a base actually. Okay, and it is a stronger base than amine. Like example I told you, pyridine, which remove HCl so formed, and after shift the equilibrium to the right hand side, from left side to right hand side. Means example, for example, ethanamine. Ethanamine, when it will react with acyl chloride like CH3COCl, CH3COCl, then what will happen? That C2H5, ethanamine means C2H5 NH2. Then here 2H is there and N has a lone pair of electron. Then that lone pair of electron will be given to carbon of acyl group. Here you have taken acetyl. Okay. Then means CH3COCl. Ethyl amine is reacting with CH3COCl. Okay. This is the acyl chloride. Then here what will happen? Then lone pair of electron of nitrogen will be given to carbon. Why? Because with carbon COCl, oxygen is double bond. That bond will break. Then oxygen will become negative because it will take the electron and carbon will become positive. Due to this reason, nitrogen will give electron to this carbon, positive carbon, and it will make a bond. It will make a bond. Okay. Then after that, what will happen? That this here that new bond formed. And now it became C2H5 with N2 hydrogen. 2 hydrogen was already attached and third new bond formed with nitrogen and carbon. Then after that what will happen? That here from the N, because now N is positive charge. N is a positive charge because N has donated electron to carbon. Then that is a positive and that is becoming unstable. Then what will happen? That 2H is there attached with N, then 1H bond will break and it will go as a H plus and electron will be taken by the nitrogen which is positively charged. Then to neutralize this charge, actually hydrogen will go as H plus and electron will be taken by nitrogen. Then now it will become normal, neutral. Okay. And H will go as H plus, then that H plus, now it will go to the Cl. Okay. And there that carbon and Cl bond will break. Carbon and Cl bond will break. Then Cl will be negative and carbon will be positive. Then oxygen has negative and carbon is positive. Then oxygen will make double bond there. Carbon and oxygen single bond was there and it is negatively charged. Then now that electron will make a double bond with carbon and oxygen and Cl will go as Cl minus. Then H plus and Cl minus, it will form HCl. Then what product you got now? Main product. Then C2H5 NH because one H gone. NH and N and carbon has joined. Then now C has a double bond. Carbon oxygen double bond and by that carbon CH3 is attached. Means C2H5N, C2H5NH, CO, CH3. This is called N-ethyl. N-ethyl ethanamide. Correct? Because from the N, ethyl group is attached That's why N. It is called N-ethyl. Ethanamide, because COCH3 is there, then 2 carbon is there, then it is called ethanamide, because it is COCH3. Finally, it is a COCH3, CO, that carbon and CH3, 2 carbon is there. That's why it is called ethanamide. And final name is N-ethyl ethanamide. Now, second reaction I am telling, actually what I told you, only primary, only one ethyl group is there. Now suppose 2 ethyl group is attached. 2 ethyl groups are attached with N. Then with N only 1 hydrogen will be there. It is become secondary amine, because 2 ethyl group is attached. 2 hydrogen replaced with 2 ethyl group. Then it is actually secondary amine. Okay. Then it is called actually N-ethyl ethanamide. N-ethyl ethanamine, because 2 C2H5 group is attached with N. With N only 1 hydrogen is there, and this N has lone pair of electron. Then again, if it will react with CH3COCl, then what will happen? Same type of reaction will take place. Same reaction what I discussed, that nitrogen will make bond with carbon, and H will, from the nitrogen H will leave, and from the CH3COCl that Cl will leave. Then one more product HCl it will form. Same way what I had discussed. Then you will get now here all thing will be the same. First time what I told there, NH C2H5 NH was there. Now in the place of H, one more C2H5 will be there. Means C2H5, again one more C2H5, no H, and that N is joined with CO, and that CO with that C, CH3 already is joined. This is called N. N means nitrogen. N, comma N. N diethyl ethanamide. Okay, and now another reaction I am telling you, that is the benzyamine. Benzyamine means this NH3 was there, 1 H is replaced with phenyl group. Then 2 with nitrogen, 2 hydrogen is there. Third hydrogen is replaced with C6H5. This is called benzene amine. This is called benzene amine. Okay. Then this benzene amine, and again suppose this ethanoic anhydride is reacting. Ethanoic means CH3CO, in the middle oxygen is there, again CH3CO is there. Oxygen with oxygen to CH3CO is attached, one left side, other right side. And now here again similar type of reaction will take place. That you know that what will happen, that one CO bond will break, single bond. In the middle oxygen is there, then C and O, CH3CO, this is joined with the oxygen, middle oxygen. Another is also CH3CO joined with middle oxygen. Then that one bond will break. Then you know you will get 2 parts. One you will get CH3CO, 1 part. Correct? That carbon CH3CO, that C will have positive charge. Other part will be CH3COO. You know that one oxygen is joined with carbon with double bond, and other oxygen is single bond. But this oxygen, single bond oxygen will take this electron, and it will become negative when bond will break. Then now what will happen? You know that this from the benzene amine, when hydrogen gone as H plus, then nitrogen became negative. Correct? Then with that negative plus C plus, actually when bond broken in anhydride, then you got CH3CO and C was plus, that will join with nitrogen. Then now we'll get C6H5NH. N and C now bond is formed. N was negatively charged, carbon is positively. Correct? Hence you got C6H5NH and with carbon single bond. And C double bond, oxygen is there already, CH3 is there. CH3CO already joined. Then you got finally N-phenyl. N-phenyl ethyl amide. N-phenyl, because from the N-phenyl group is attached. That's why name is N-phenyl ethane amide, because CH3CO has joined. That is the amide. Okay. Then you can tell it as a N-phenyl ethane amide. Also you can tell acid anilide. And what will be the other product? Because when anhydride broken, then you got two part. Then second part is CH3 COO 1 minus. Then H plus from the NH2. That H plus will come near the oxygen, O negative, and it will form CH3 COOH, means acetic acid. Then you got two product, that is the N-phenyl ethanamide plus acetic acid. N-phenyl ethanamide is also called acid anilide. Okay. Amines also react with benzoyl chloride, C6H5COCl. Correct? It can react. It's a very, very important point or important reaction, that amines also react with benzoyl chloride, means C6H5COCl. COCl actually is called acid chloride, remember. Then amines react with benzoyl chloride, means C6H5COCl. This reaction is known as benzoylation reaction. Benzoylation. Okay. Benzoyl, from that it became benzoylation reaction. Reaction is very simple. CH3NH2 plus C6H5COCl. Then you know what will happen. From the NH2, CH3NH2, from that one H will go as H plus, then N will become negative, and from benzoyl chloride, Cl will go as Cl minus, then that carbon will come positive, then that positive carbon and a negative nitrogen both will join. Then you will get CH3NH. From that N, now this C6H5 joined. C6H5 joined. Okay, because Cl gone as Cl minus. Then carbon will get positive charge. Then this positive carbon will join with N negative, because this methanamine from that H gone as H plus, N became negative. Then this N negative and this carbon CH3CO, that carbon will join with N. Then it will form CH3NH, C6H5CO. That is called N-methyl benzene amide. Other product will be HCl. Okay. Now next reaction I am telling you, that is very, very important reaction, that is called carbyl amine reaction. Most important reaction, carbyl amine reaction. Always it is, this reaction is asked, okay, in examination. What is carbyl amine reaction? Now I am telling. Aliphatic and aromatic primary amines On heating with chloroform and ethanolic potassium hydroxide form isocyanide. Isocyanide. Isocyanides is also called carbyl amine, okay, which are foul smelling substance. You will get a special type of smell that is called foul, F-O-U-L, foul smelling substance. Okay. Aliphatic amine, again I am telling you, aliphatic and aromatic primary amine on heating with chloroform in the presence of ethanolic potassium hydroxide, means potassium hydroxide is dissolved in ethanol, or in the presence of ethanol, that is called ethanolic potassium hydroxide. After the reaction, it will form isocyanides, that is also called carbyl amines, and these carbyl amines are foul smelling, foul, F-O-U-L, foul smelling substance. Secondary and tertiary amines do not show this reaction. This is again important point. Only primary amines, aliphatic and aromatic primary amine only goes this reaction, not the secondary and tertiary amine. Secondary and tertiary amine do not show this reaction. Question is asked. Okay. This reaction is known as carbyl amine reaction. Correct? Aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide form isocyanides and carbyl amines, which are foul smelling substances. This reaction is known as carbyl amine reaction, also called isocyanide test, and is used as a test for primary amines. Reaction is very simple. RNH2 plus CHCl3, this is a chloroform. Only one hydrogen is there. In methane, 4 hydrogen, there will be 4 hydrogen, 3 hydrogen is replaced with 3 chlorine atom. Only one hydrogen is there. CHCl3, this is called chloroform. Then RNH2 plus CHCl3 plus 3 KOH. When these 3 are heated, then you will get RNC. RNC, not RCN. Means here R and N. N has joined with R. Correct? N has joined with R. It is called RNC, not the RCN. That is the cyanide. If carbon will join with R, means alkyl group, that will be cyanide. But here is N is joining with R, RNC. That is called isocyanide. And other product, second product is 3KCl. 3KCl, because 3KOH you have taken and CHCl3, 3Cl is there. Then obviously it will form 3KCl. And you know that when K will go and when Cl will go, then they will create opposite charge. Cl will go as Cl minus, then carbon will get positively charged. And when K will go from KOH as K plus, then OH will become negative charge. Correct? Then you will, first product you got RNC, second product 3KCl, and finally actually there's a total hydrogen. Now you can see RNH2, 2 hydrogen was there, CH3, 1 hydrogen is here, 3 and 3 KOH, 3 hydrogen, total 6 hydrogen, and oxygen is 3 KOH. 3 KOH means 3 oxygen, hence it will 6 hydrogen, 3 oxygen. It will form 3H2O. This reaction is very, very important point. Okay, means you will get RNC first product, second product 3KCl, third product plus 3H2O. 3 why you have taken? This is the requirement, correct, to balance the reaction. Now next reaction is reaction with nitrous acid. Reaction with nitrous acid. Then here three classes of amines react with differently with nitrous acid, which is present in C2 form. C2 I am telling again, it's three classes of amines react with differently with nitrous acid, which is prepared in C2 SiTu situation, C2 from a mineral acid and sodium nitrite. Then I am telling you first, primary aliphatic and amines react with nitrous acid to form aliphatic diazonium salt, which being unstable liberate nitrogen gas quantitatively and alcohols. Quantitative evolution of nitrogen is used in estimation of amino acid and protein. This reaction is very important. Reaction is simple. RNH2 plus HNO2. Then here in presence of NaNO2 plus HCl, it will give Rn2Cl minus. N2 1 plus on nitrogen, N2Cl. Then on N2 plus will be there and Cl minus there is there. That is the salt. It is called diazonium salt. Correct? Azo group, what you are telling. Rn2Cl. This is called diazonium salt. Always remember N2Cl. N2 is positive charge, Cl is negative. That's why it is salt. Then it forms Rn2Cl minus. And this is unstable. This salt is unstable. Hence on hydrolysis, if you will heat it, hydrolysis you will do, it is unstable. And it will, because it is unstable, this actually liberate nitrogen gas and alcohol. It will, this unstable diazonium salt liberate nitrogen gas quantitatively and alcohols also it forms, and HCl will also form. Means you will get three product. Rn2Cl on hydrolysis, it will give ROH plus N2 plus HCl. Okay, nitrogen gas you will get. Now second reaction I am telling you, this reaction is very important. You remember, formation of diazonium salt is important reaction. RNH2 plus HNO2. How will you get HNO2? Then you will get from the mixture of NaNO2 plus HCl. That will provide you HNO2. Reaction is simple. NaNO2 plus HCl. It will form NaCl plus HNO2. That HNO2 it will react with RNH2. That's why we are telling that you will get HNO2 in C2. Okay, from a mineral acid and sodium nitrite. Now sodium nitrite, okay, not nitrile, nitrite. Second reaction I am telling you, aromatic amines react with nitrous acid. Aromatic amine, I told you that was the aliphatic amine. Now it is aromatic. Then you know all things will be the same. Only 6,6H5 group will be attached. All things will be the same. Condition may be little different. Aromatic amines react with nitrous acid at low temperature. Low temperature means 273 to 278 Kelvin. And it will also form diazonium salt. A very important class of compounds used for synthesis of a variety of aromatic compounds. Then already actually this reaction discussed previously 2-3 times. Again I am telling you mechanism also I have discussed. Here C65NH2, that is the aniline. it will react with NaNO2 plus 2HCl. Same condition, only temperature is only 5 degrees centigrade, means less temperature, very less, 273 to 278 Kelvin, not in degree centigrade, that will be 5 degrees centigrade. Then it will give same type of product, C6H5N2Cl, salt. This is called benzene diazonium chloride. This is again unstable, correct? And other product you will get, that is the NaCl plus 2H2O, means C6H5NH2 in presence of NaNO2 plus 2HCl at 273 to 278 Kelvin, you will get C6H5N2Cl, N2NH plus positive charge, Cl negative. This is called benzene diazonium chloride plus NaCl plus 2H2O. Okay, secondary and tertiary amines react with nitrous acid in a different manner. You remember here, secondary and tertiary amine react with nitrous acid, that will also react, but that will react in different manner. Okay, then now I am stopping only here. Next class actually more reactions are there. Then next class I will continue. Okay, thank you.